Assalamualaikum and good evening. My name is Nurul Atika binti Johari. My matrix number is 203222. My friend SIM Wei Feng 203689 and Pravishnu anak lelaki Mahadevan 203654.
So we move to the question number 3. So in this question, we need to find the minimum required diameter for the two shaft, brass shaft and aluminum shaft. So we have two segments here, and what the information we got here is the allowable shear stress 60 megapascal for the solid brush shaft, while 90 megapascal for the aluminum brush shaft. So the first thing to do is we cut into section, and we find the torque acting on the each section. So we know the torque acting on each section is 23,000 Newton, while the radius is d over 2, and the polymer inertia we use as it's a solid shaft, we use the formula pi over 32 d4. So we substitute all these values into the torque formula, where the shear stress is 60 times 10 power of 6. Then the torque we have found 22,000, C is DO2 and all that. We can find the D is 124.98 mm. For the second part, is just the same. We already find the torque. We have already got the polymer moment inertia formula and already got the radius formula. We substitute the same thing, but just the difference is the allowable shear stress. So we can also find the diameter. So 109.20 millimeter. So the second, fifth question, question number 5. What we need to find here is the maximum diameter of the solid steel that will not twist more than 3 degrees. And we got the information we got here is the torque, we got the length, we got the angle of twist. And from the angle of twist formula, we can find the values. So first we need to find the diameter. So we need to use the formula angle of twist, tau L over GC. So we got the G, we got the L, we got the angle of twist. So we need to find the C and also the tau. So we can relate this both tau and C by the formula of tau and also the polymer moment inertia. So TC over J and J equals to pi over 2 C4. We combine the both formulas in one. We replace in tau equals to TC over pi over 2 C4. Make sure we change the degree into radian first. Then we substitute the tau that we change into the angle of twist formula. So we make C into a subject, then we can find the C. So they since asked for the diameter, we times the C into 2 because C is the radius. We times 2, we get the diameter is 113.98 millimeter. Then the second they ask is maximum shearing stress developed. So we use the same formula of shear stress equals to tau C over J. We got the torque we got the C radius we got the J. So we just substitute the formula, we get 41.28 megapascal.
For question number 7, it requires us to find the largest value of the sigma y, which is the maximum shear stress is 55 MPa. So from the figure, we know that sigma y is positive as the arrow is pointed outward, and the sigma x is positive 92 as the arrow also pointed upward, and the shear stress is 38 MPa positive as the arrow is pointed towards the positive axis. So we use the formula T maximum plus minus and enter all the data into the formula, and we will get two value, which and we choose the largest value as it requires us to find the largest value. Next, for question number 7, 7B, it requires us to find the corresponding principal stresses. We key in all the information into the formula, and we will get the maximum normal stresses, which is sigma P1 186.76 MPa, and the minimum sigma P2, which is 76.76 MPa.
Okay, for the question 8, we are given the force is 250 Newton. To find the normal stress, we use the normal stress formula. Stress equals to force per area, and we get 0.167 MPa, and the stress in Y is 0 because the force in Y direction is 0. Therefore, there's no shear force and torsional force, so the shear stress is also 0. On the right hand side, the drawing shows the stress acting on the block. Next, we calculate the inclination plane. Okay, for the inclination plane, the normal stress will be perpendicular to the inclined plane. Then the x is horizontal plane. So the rotation should be between the horizontal to the transform plane. For this case, the transform plane is x prime. Then we have to find the angle, knowing that the angle between the x prime and the y prime is 90 degree. So the angle is 90 degree minus 20 equals to 70. The sign is positive, okay, since the horizontal x to the transform x prime axis is counterclockwise. So then we just substitute the values using the formula below to find the sigma x prime, sigma y prime, and the tau xy prime. Then we talk about the Mohs circle. For the Mohs circle, we calculate the Mohs circle. Oh, okay. For the Mohs circle, we calculate the center of the Mohs circle using a formula. Knowing that the shear is equals to 0 and the center is located at sigma axis. So we just plot the coordinates, the normal stress, average, and the 0 on the paper. Then calculate the radius using formula, and we get 0.0833 MPa. And then we just draw the circle from the center of the point with radius 0.0833. Okay, the sigma x is positive, so point plotted on right side on the tau axis. Since the tau xy arrow tends to rotate the stress element clockwise, the point is above the shear axis, the sigma axis. Okay, then we just label x point and y point. The principal stress can be calculated by using a formula. And for the major principal stress, the formula is C plus R. And the minor principal stress, the formula is C minus R. Okay, the principal stress can be also observed occur at 2 points when the circle crosses at sigma axis. Okay, that's all for our presentation. Thank you.